here's what we're doing. We're talking about something called the Yale Building Project, and we have two of the folks who are very intimately involved in that project. We have Mr. Adam Hopfner, who's the director of the building project, as well as Katie Stranix, who's been one of the student leaders of the team that's actually working on that project with Adam. And so to set the stage a little bit, the Yale Building Project is a fantastic experience. It's something that the first-year master's students at Yale do at the end of the first year, where we take a project from the design concept all the way through building it out there in the field. So the students actually go through and do all the construction documentation, get the permits, and ultimately build that project across the summer. So it's a fantastic project. I had the honor of actually going on back and helping out a little bit with the technology to make some of that happen. So again, I'm William Katz, the AEC specialist in education for Autodesk, and I'm being joined today in this endeavor by Mr. Adam Hopfner, who's the director of that Yale Building Project. So Adam, why don't you go ahead and introduce yourself to our audience and just tell, say a few words about sort of your involvement in the project and how you think about it.
Sure. Thanks, Glenn. My name is Adam Hopfner. I direct the building project. I've been the director of the project for, I think this is my 6th year now. It is a required course for first-year graduate students, first-year MR1 students, whereby they enter into a design competition where for the first time they're actually working in teams. We divide them or help them divide themselves into teams of about 7 people. And they enter into a design competition to, in this case, to develop a scheme for a 2-family house within the city of New Haven, a particular lot within the city of New Haven. And those schemes are worked on with faculty for about 4 weeks. Mm-hmm. And at the end of which we, along with the client whom we're working with, select one of those schemes, and in about a week's time after we choose the winning scheme, we're actually digging a hole and beginning the actual construction.
Fantastic. Fantastic. I think that's a great starting point. Let's go ahead and have Katie introduce herself, and then we'll just start marching through, because really what we're going to do for the whole webinar is kind of walk through that process and kind of think about really how different folks have been involved in that and really what you're accomplishing now and what we're going to be accomplishing over the summer on the project. So Katie, why don't you jump in and tell us a little about yourself?
My name is Katie Stranix. I'm one of the 2 project managers, student project managers. And basically Bob Scott and I work with a management team trying to get all the students just working on the project and collaborating and making sure that everything's coordinated. So.
Fantastic. That's a great place to get started. Now, let me go ahead and actually invite the other participants in this webinar to kind of join us too, though, and that are actually folks who are listening in there. So we want this always to be sort of a very interactive thing. So for the virtual attendees, for you folks out there hanging on GoToWebinar, please, if at any point you want to ask some questions, and this is all about discussion and giving the opportunity to ask questions, so either raise your hand or type, there's a button in the interface where you can raise your hand, and we'll go ahead and give you the opportunity to ask your question directly there. Or if you want to just type into the chat window, you can do that too. Either way, but go ahead and make this an interactive discussion, because having Adam here, having Katie here to actually answer your questions and really kind of think about how you could be sort of taking some of the experience that they're creating there at Yale and do it in your own classrooms or in your own settings is really what this is all about, to kind of inspire you about how you can kind of take the best lessons and go with some of those things. So let's go ahead and do this just to kind of set the stage for really what's going on. We'll tell a little bit the backstory of the whole building project. So let me go ahead. I'm going to turn the screen over to you guys, and we'll just let you go ahead and walk us through a little about the history and just sort of how we got there this year in terms of the competition and some of the designs that we considered that really were the ones that we ultimately selected and started illustrating with the modeling. So go ahead and take it away.
Okay, great. Well, the history of the building project at the School of Architecture at Yale, it's a long and perhaps storied history. It began back in the late 60s when Charles Moore became the head of the school. And he was sort of attempting to both harness the social unrest of the time, I think, and also to sort of knock down some of the walls of the Ivy Tower, and began to try to redefine architecture as a sort of a social endeavor. And perhaps it was in response to some of his predecessors' more ethereal views about architecture when Paul Rudolph was the head of the school. But in any case, Charles Moore began this endeavor with Kent Bloomer, and in the early years, they actually went down into the hollers of West Virginia and various places, building community centers and so forth. Over the as the sort of time progressed, and budgets shrank depending on the economy, the sort of the social agenda of the building project had to accommodate the realities. So while we were first doing that, not we, but while they were first involved with community centers and so forth, it migrated into dealing with sort of smaller interventions, camp structures, pavilions, beach pavilions, that sort of thing, through the 80s. And then eventually we, I would argue, sort of reinvested in the notion of the sort of social agenda of the building project and began focusing here at home within the city of New Haven, and began to look at the housing needs and began to develop at first single family and now recently two-family houses. And for, let's say, 24 perhaps consecutive years, we've been each year building a single house or a two-family house within the city of New Haven.
Could you comment a little bit about, I know the context of where this house is built, kind of the social dynamics, and really this whole notion of a two-family house and how that plays into the affordability is a big piece of what's going on in the whole social, we're kind of creating a new model for really, what's happening in the neighborhood. So, can you comment on that?
Yeah, well, like I said, for a while we were simply building single-family houses, but when we started to do a more thorough analysis of what sort of affordability means and looking at it through the lens of all the subsidies that we as Yale have in place, meaning the free student labor, the practically free faculty labor, we began to look at how mortgages break down and so forth and so on, and by moving to the model of a two-family house, it allows the owner to rent a unit and substantially pay down the mortgage. So while the labor and a lot of the materials that we work with are free or donated, there's still a significant cost, of course, constructing a house. And the developer that we worked with, whether it was Common Ground, who we worked with for 4 years, or now Neighborhood Housing Services in New Haven, they still have to effectively sell the house, and while it's sold at a substantially reduced rate, it still requires the first-time home buyer to incur a pretty significant cost. And again, by using a two-family house, that mortgage, the monthly mortgage payment is reduced, somewhere 40%, somewhere thereabouts. Now, if you assume that the rental unit isn't going to be rented all the time, that those numbers change a little bit, but it's a significant way of addressing issues of affordability, and obviously addressing, at least touching upon issues of sustainability and having a smaller footprint and sharing, thermal conditions and so forth.
Now, I have a question for you on, is this really a very special one-time house, or is this something that the developer is likely to, try and seed the neighborhood with and, repeat a little bit? So, how is this one house viewed relative? Yeah.
Right. So just a little bit of background about this. I mean, the city of New Haven is fairly common of northeastern cities, at least, in the U.S. where there was a significant sort of depopulation that occurred post-World War II, and the result of which is that there are quite a few sort of gaps in the, sort of missing teeth within the fabric of the city. And so what we at Yale try to do is identify some of those various gaps, and we acquire those lots with the developer. And so the schemes on the one hand are very specific to the context within which they find themselves. This year we're building on a corner lot, so a lot of what the students wrestled with was how to sort of deal with the fact that a building essentially has two faces. And so in that sense it's specific. On the other hand, I guess when I started taking over as director of the project, we began working with an organization, Common Ground, which is quite a large and innovative nonprofit developer based out of Manhattan, started by this woman, Roseanne Haggerty, who won a Genius Grant to essentially end homelessness. That's the mission of this organization. When we were working with them, we targeted the potential home buyer as being returning female vets. That was motivated by the fact that somewhere between, depending on who you ask, 25 to 30% of all homeless in America are vets. Given that a large amount of the military are now made up of females, we began to sort of proactively try to bring light to this issue. And so we were developing schemes that were particular to their sites, but at the same time, we're conceiving of them as sort of prototypes that could be deployed throughout wherever this organization, Common Ground, has footholds. And so the schemes were developed to be able to adjust themselves depending on the context within which they found themselves. So students developed not only the particular scheme, but also the sort of the ability for that scheme to morph or change depending on the context within which it might define itself.
And that makes it really a much more interesting and complex design problem to really have to think about not just a single solution, but actually something that could then really be a prototype and be morphed that way. Actually, I have a question for you about I'm just wondering
No, I was just going to say that.
Please. Oh, no, go ahead. It's like, you're going to find we walk over each, it's really hard with the timeline. So go ahead. Don't be shy about it.
I was just going to say that along with that, when we were looking at sort of the notion of prototype, was that while in the case of the actual building that we constructed, it was, again, sort of free student labor and so forth, that we were looking at the economics of it and the methodologies of construction with the assumption that it wouldn't be 50 students climbing all over one another, on the site, that perhaps this thing could become economically viable in a real market condition. And so that was another issue that the students were forced to wrestle with.
Fantastic. Actually, I think people are probably clamoring to sort of see what the houses actually that we're working on this year is looking like. So Katie, can you go ahead and show us some of the competitors, some of the ones that students came up in response to this, and just kind of talk us through some of those and why we got to the house that we actually did work on.
Well, we had 8 different teams of students. And everyone was kind of dealing with the site conditions differently. And so you had certain teams that were concerned with having smaller footprints or more efficient footprints. For instance, this team was really trying to look outward towards the site, but not occupy that corner condition instead of instead of an L-shaped design, which other people decided to explore. So these are just some images of that house. And then the winning design is this house. It's changed slightly, but was still interested in engaging that corner or the intersection of Star and Newhall, but also allowing the the owner intended to have a backyard. You can see in some of these diagrams, these are just elevations.
Is there a plan of this?
Yeah, I think down here.
Actually, I think one thing that some of the faculty would be really interested in hearing about is really, it's your whole process of how you got to here, because I know when I try to put like 7 students together as a design team and try to say, come up with a shared design, that's usually quite a task. So how did your teams work? How were you able to kind of take this? It's really a pretty big challenge and come to these different solutions, and then really how did you even choose in the end which was going to be the one that you implemented?
Well, yeah, the student, you're right that there are 7 really, how shall we say, strong-minded, opinionated students.
Pardon me.
Have probably, taken on the Howard Rourke sort of sole genius architect for the past however long their careers have been, and to actually, part of the pedagogy of this is to actually have them begin to engage not only with the external forces of community and politics that exist and developing a house within a community and having to reconcile their design ideas with things like building codes and zoning regulations and so forth, but also looking at the internal forces that come to bear on how designs are developed, i.e. that you're not, for the most part, people are no longer sort of designing by themselves, and that so this level of interaction is something that's obviously intentional within the structure of the course. The students, they attempt to sort of self-select whereby we identify different themes or points of departure that students might be interested in, and then through a lottery system they sort of not blindly, but they select which ideas they might be more or less interested in. Teams are formulated that way, but then the 7 students come together, and it is a bit of a struggle to have them develop a single voice over the course of 4 weeks. The case of the house that actually won this year, which I think you guys are all looking at the plan of which now, they were sort of a disaster for the first 2.5 of the 4-week process, and they were all over the map. And sometimes that's the case where people are really struggling to define their goals as a group, and once that is defined, then they can coalesce around an idea and develop a team. Other students, other teams work really cohesively from the beginning, and it's a little bit difficult to say. There is, having done this for a number of years now, there is no sort of single process which actually consistently bears fruit in that one sort of organizational structure repeatedly wins the competition. I will say that we have brought in faculty from the School of Management, the business school essentially at
Really?
at Yale, and have them talk about issues of collaboration theory and organizational structures, and at least try to raise the level of consciousness within the student groups as to how they might begin to develop a singular voice from the voice of 7. And it has been, I don't know, maybe Katie can speak more truthfully or more accurately as to how successful that's been. But it is a challenge that we intentionally build in as part of the design problem, that we're asking the students not only to design a scheme, but actually designing the process that manifests the scheme.
Yeah, I think that's actually one thing that we saw in the week that I was there, was that with that foundation laid, I think that people were really amazingly collaborative and could really work together, in a very large group and didn't take anything too personal. We really did seem to be working on a shared vision and the importance of sort of achieving that in a short period of time to all of us. Like, Katie, I know one thing in talking with you and some of your colleagues, this notion that the experience we had, it was kind of like working in an office. It was very different than sort of just being in a studio, and I think that kind of really motivated people. Can you comment on that?
Well, I think that comment stemmed from us all being in the same room for consecutive days at a time, and there were probably 15 to 20 people working on the same file and all talking to each other about changes being made and kind of making sure that the person working on the plan was updating to include what was changing in the elevations. And so it was really great to have everyone in the same room working on the same building and really kind of working out the kinks and discovering issues and then talking about them openly. And it was nice to have people working, but also people not working and just observing and kind of floating. And so in that way I felt that it was more office-like because everyone working on the same project was clustered in one zone. But it was very effective, I thought.
Very good. Actually, why don't we go ahead and move into the notion of really how we accomplish this, because really in that week an incredible amount got accomplished really in terms of producing a lot of details in CAD systems and some traditional systems as well as in 3D modeling. And Katie, can you give us sort of an overview of what went on that week? Because I think you saw it from both sides. You were sort of in the middle of that.
Right. Well, we had initially discussed having two parallel paths to produce the CD set or the permit set, and we were going to have a CAD group and then a Revit group. And halfway through the week, we realized that the Revit model became updated enough or kind of complete enough to derive all the drawings from. And we realized that it was more efficient to produce the set from Revit than to have everyone kind of working from CAD. But now, after we've produced the initial set and are now trying to get down to the details, I think we're switching from Revit to CAD to kind of figure out just more, I don't know, the stair railings and certain cladding details. But the Revit has been great because for the project as a whole, just making sure that everything is in place, the windows are all aligned, it's been a great tool.
Great. Actually, Katie, why don't you go ahead and release the screen there. Let me go ahead and bring up the Revit model. So as we're talking, we get people actually see what we were working on together there. So I'm going to share the screen on my side, and I'm just going to bring up the model so people can actually see what we were doing. Okay. So yes,
I'm sorry,
Adam.
I was going to just say that while you're doing that, let me just comment sort of from a faculty's perspective, who's again. Yes. A bit of a Luddite when it comes to this technology, and I'm dragged kicking and screaming to the 21st century here. We intentionally, as Katie said, sort of developed two parallel tracks. Part of which was based on sort of skepticism as to whether the students could actually learn Revit quickly enough to fit into the schedule. Which is a really insane sort of schedule of Sisyphus, trying to within a week's time after a design scheme, which, it would be generous to call it perhaps a DD set, design development set. Within a week's time from selecting that scheme, actually getting all of the permits in place and chasing it through the various, agencies. To produce a set of documents that quickly is a pretty heavy lift. And so we, like I said, given that there were 50 students in the class, we split them into two teams, one of which was a more traditional two-dimensional CAD documentation, and the second was Revit. And it was really fascinating to watch the two run in tandem to one another.
Agreed entirely. I think we actually learned a lot more by having them work separately and then to start to see where the advantages were of each of the different technologies. And something really interesting happened where I think we sort of met in the middle, which is really, to me, a great outcome.
I think that's true. And again, while we were quote unquote simply documenting this building, it wasn't purely documentation that was occurring. There were a lot of issues, even though the scheme was selected, there were still a significant amount of issues that needed to be addressed within the design itself, independent of the documentation of the design. And so at that time, I mean, observing it as a faculty member, I would say that it wasn't in either or as to whether 2D or the Revit model or actually physical, physical models were constructed. It was just it was more of a both and, where there was overlap between the various techniques of looking into these design issues, and the one would inform the other, and so forth and so on. So it's quite a fascinating process to be a part of.
Well, I think it was for me too. And actually, what I'm showing on the screen now, just so folks who are watching can sort of know, these are examples of the actual drawings that kind of came out. Things like the framing plan, the mechanical plan. So these are the pieces that came out of the model that ultimately, like a lot of them were enhanced using CAD techniques to kind of like go ahead and fill out some of the different details. In some cases, we used CAD details, bringing them in to help generate the 3D model. In other cases, we took things out of the 3D model and took them over to CAD and add detail there. It was really a combination of all. And then what we spent a lot of our time doing was working in these kind of fairly realistic 3D views, which I think really gave the students kind of a nice insight in terms of what we were really designing, because as opposed to looking at everything in terms of floor plans and elevations and trying to resolve that, I think really in a lot of these 3D views, people were starting to really experience what the design was going to be like. And the design actually morphed a fair amount through the whole week, I think, because we could see it and realize places we could make the design better. So Katie, talk about that week and because there were a couple times I really enjoyed where people did all get together and we had a really collaborative experience. But go ahead and talk about how we collaborated.
Well, it's kind of what you said before. We started out as completely separate groups, and then basically some of the people from the Revit team started coming upstairs and saying that, oh, we ran into these issues, because they were working from our CAD plans. And so they were, we ran into these issues. Can you guys look at the model? Come downstairs. We'll talk through it. And basically the whole class was split up into different groups to explore kind of the different conflicts that needed to be resolved that week. And so it ended up being just a large group of us downstairs, people from the mechanical, electrical, plumbing, structural teams, and then people that have been working in the plan, on the site, and the Revit model, all were talking. And by the weekend, there were less people, but it was more, everybody knew what was going on. There was a lot of communication.
Mm-hmm. One of the interactions that I really sort of enjoyed was as we were kind of messing around with pieces of the floor plan and trying to think about where things would work, there were some things where, for example, in the kitchen area of the owner unit, like this little corner right here received an awful lot of loving detail. At one time it seemed there were 8 people. We had the several architects, we had the structural engineer talking about his requirements, the mechanical engineers talking about what needed to happen, and really this whole detail about how that corner got opened up, how the structure could still be supported, and even how what happened was like the HVAC system ended up moving across the room a little bit into a chase. How all those things could play out relative to each other. There was a really nice interaction there where somehow getting everyone together in the same room, be able to see and test things, really it led to sort of a very nice kind of collaboration where I think we all came up with a much more creative solution than anyone would have on their own desktop. Anything else about that? Yeah, please.
I was going to say, I think that's true, that sort of collision of geometries and so forth is something that wasn't reconciled. And when you begin to overlay sort of the integration of mechanical systems, the space requirements for that, as well as actually the things like dealing with gravity, like how floors are actually held up and so forth, that became a piece that we had to reconcile. And to be honest, we are still doing that. In fact, what I'm looking at on the screen now is not where we are. I don't know if this is an earlier model. It's still sort of a point of contention. And again, we're using, I think it was yesterday or 2 days ago that I said, I don't know, can I use a mouse to point at something? Like looking at sort of the sectional relationship of the stairs to one another, that whole piece is still continuing to be studied.
Let's even bring that up, because that was one of the things that really, even during the week, I think we ran into some things in 3D that we saw there, and it was really only by looking at it here we started to understand it's the head height requirements between the stairs and the relationship between the owner's stair and the tenant's stair, and it's really very tight and very complex about what's going on there. So even as we continue to work today, that continues to be an area that we're focusing on and trying to figure out?
Yeah. I mean, I think, again, the requirements are now pretty fully understood, and now it's a question of sort of, being the architect in terms of making sort of value judgments in terms of the spatial complexity and the desires that we as sort of shapers of space have. And there's, I guess the other thing to say is that not only with the stair, but with that cabinet, if you go back to that other view with the...
in the kitchens where we had the chases?
Yeah, where this, this, can you see my arrow? No. Okay. See that sort of column thing just to the left of where you're pointing now? That seems to me, when I take off my contractor hat and put on my architect hat for a little bit, that seems to be terribly problematic as just sort of this freestanding column as to what it's doing, dividing space and so forth. And so we've actually gone back and revisited that, and now that kinked wall by the foyer space has now been reconceived as almost a full thickened wall, which embeds the mechanical as well as the structural, as well as all the sort of the high stuff of the kitchen. So it's this thickened thing that you move through, and it allows the dining and the living space to be more explicitly linked to that front entry piece, which then, again, that's sort of conceptually in keeping with the notion of that shifted plan responding to the larger site issue of how you deal with a corner and to create a private space, but still address, sort of make a massing sort of gesture to the corner, but still begin to connect the programmatic pieces. And again, there was both the Revit model and as well as the CAD drawings and the physical model. All of these things are sort of being used in tandem, sort of reinforce one another, and we are constantly going back and trying to step back and revisit what the initial sort of intentions of the scheme were, and be true to those, because ultimately that was the reason that we selected the scheme to be built.
I think it's fantastic that it's helping us make sure that those don't get lost along the way. Actually, Katie, even for me, there's a funny thing, and I think we were talking about this yesterday in the call, of when you're looking at the 3D model, there's sort of, but it's almost a level of intuition and familiarity. I almost feel like I know the house before it's being built because I'm seeing it in such a realistic form as opposed to looking at it in the elevations and these abstracted plan views, such that we're going to show some photos of the site in just a minute. Somehow when things show up on site, the fact that I've seen it in 3D, I sort of feel like I know it before it ever got there. And so I'm just wondering, your feeling about how being able to sort of see things in these sorts of views impacts you as a designer, as you're thinking about things as, how does that add to the process to be able to kind of see these things and sort of experience them, almost before they're going to be, really before they're going to be built? Like, for example, that column, was being able to see it here and understand that we're not really meeting the original design intent, was that valuable because we corrected it now as opposed to 3 weeks from now?
Well, yeah, I think the 3D model, especially in terms of the stairs, I think that was, that's the most helpful piece of it, because we were able to see, because in the CAD drawings we hadn't drawn it fully in section yet, and so having that constructed in the 3D model first was very helpful. And just for, I think most of since the building, the mass of the building kind of peels back in certain locations, it's nice to see in the 3D model as opposed to the elevations how that's working and what the overhangs are doing. I think the 3D model was very helpful for that.
Fantastic.
I actually don't have the site photos on this computer, so I can't show the foundation, but we do have excavation photos.
Oh, great. Okay.
Yeah.
Let's go ahead and take a look at those, because actually let me turn it back over to you, because the next step would really be, let's just kind of update people about what's going on right now, because we've moved from this, the permit's been pulled, and you're actually doing some cool stuff out there on site. So let me turn the screen back over to you guys. And, oops, wrong one. See if it's this one. There we go. I'm going to stop sharing. Go ahead and take back over and show us sort of what the current status is. And I think it's sort of a really fantastic thing about this notion of this prefabricated foundation system and how that's all coming together and how quickly you put that together. So Adam, you can kind of walk us through a little bit how that worked.
Sure. Yeah. I mean, the foundation system that we're using this year is like you said, it's a precast foundation system. It's using 5,000 psi concrete. It's actually made in Hudson Valley, New York, a company called Superior Wall. And instead of being a full 10-inch thick monolithic concrete wall, it's actually a 2.5-inch thick wall with a series of concrete studs every 24 inches, which, it's reinforced in such a way that it allows for about a 70% reduction in the amount of concrete used. So when we begin to talk about issues of embedded energy and so forth and so on relative to the acquiring of Portland cement, it's a pretty interesting product. You can see in this picture here the excavation that took place. The students actually don't drive the diggers, the excavators. We actually do sub that out. But you can see that there's a layer of crushed stone across the whole basement area. And the use of this prefabricated foundation system actually allows us to use a crushed stone foundation as opposed to a typical 20-inch or so wide cast foundation upon which a typical foundation will sit. So that the foundation is actually just compacted 1/2-inch crushed stone. And then the foundation, once the hole is dug and all the levels are set, the foundation arrives on a truck at 8 in the morning, and then in these panels, which are they're about 8 foot 2-inch high, I think, and they're up to 14 feet long. And these panels get set one next to another, and by the end of the day, literally, the full foundation is up and ready to receive a concrete slab the next morning. So taking off my architect's hat and putting on my contractor hat, I love it because it literally saves us a week of construction time where otherwise, the students would be schlepping a lot of form work, and so this is it's an amazing, it's quite an elegant system, both from its use of materials, the fact that it's actually an R30 wall, because insulation is embedded within it, and from the time perspective, it's a really great system as well.
Great. If people are interested in sort of finding out more about all a lot of very cool, innovative, sustainable techniques you're using here, is the website the best place to go to kind of keep track of really the progress of the house and the techniques you're using? Yeah,
that's a good question. It will be.
Okay.
We're about a day away from the picture that you're looking at now. I mean, the foundation walls are up, and the website is, I guess, a day behind or so. But one thing that we're actually imagining that we can do, and again, as a 20th century Luddite when it comes to technology, I'm not sure. I'm going to depend upon my students to make this happen. But we're actually going to want to be able to have an interactive model of the building and be able to sort of click on where you could sort of zoom into different components of the building and even perhaps provide links to the various products that are being used, and that becomes sort of an educational tool as well.
Fantastic. There's actually, let me just kind of let you know, and we'll talk to the students about how to do this. There's a fantastic thing called Inventor, Publisher, which will let us take your 3D model and actually embed links to things. We can put that on the web and really give like your external audience like the ability to kind of like do some of that stuff. So let's put that on our list of kind of good things to do as we move forward with this stuff.
Exactly. Yeah.
Fantastic. Actually, Katie, why don't you go ahead and return the screen to me? I'm going to bring up the framing model because I think that's sort of something else that was sort of interesting about where we took the whole project, in that we didn't sort of stop with the architecture, but we really got into, and let me kind of bring up a framing view, really trying to plan it down in terms of as you were going through and doing the architectural design, we were using some extensions to Revit to actually start modeling the stud by stud, all the window headers and sills, start thinking about all the joists, the TGI joists and the common ones that were going to be used. Just all the structural elements got, kind of modeled also. And from that, and this is something we were trying to do because we knew that Adam was going to be very important to you as the contractor, we really started thinking about how we could then go through and start creating just schedules where we could take off different quantities and even start producing, more of a cut list of like the specific things that were going to be necessary and the quantities that you'd have to order. So like, Adam, go ahead and talk about like how the model and the quantities and how's that all working for you now as you're trying to build the house.
Well, it's interesting. Again, I'm a sort of a conservative guy, so I believe in redundancy.
Certainly.
Both structural redundancy, but also sort of quantitative. So I have asked the students to sort of generate material quantities, and at the same time, I'm taking the sheets of paper that I'm looking at out in the field, and I'm doing my own sort of calculation of counting studs and figuring out sheet goods and so forth. And then we're comparing the two, seeing where my math is wrong, where their assumptions might be wrong. And, it's pretty fascinating to look at. And we are doing that. And in fact, I had asked the students, with your help, Lynn, actually embedded within the model, as you say, all of this information. So, literally the quantity of studs can be counted, and the bottom plates and top plates and headers and all of that structural information is literally in the model. And so that's will be really interesting to see how that can be utilized for material procurement.
I'm actually very keen to sort of... I'm actually going to comment. I'm very keen to see how that works out too, because just really having some good metrics about, because we never model every last nail and every bolt and every screw, but for the major elements that we do model, like if we can get like 80% or I'm trying to figure out what that ratio is and how effective that can be. So I'm quite keen to sort of see where that one goes too. So go on, Adam.
No, I was going to say, and this is this is obviously sort of a laboratory test, and as an architect myself, when I'm designing a house for a client, and then even working with a builder to develop as bids go out and so forth. Realistically, we wouldn't. I'm not going to model every stud and so forth, and the assumptions are made. But it is really curious as a test model to see the value of this, and to be able to begin to ship this off to the structural engineer for him to do analyses. It's really a wonderful thing. One thing that when Katie and I leave here in a little bit, we're going to go meet with the student who's been looking at the sort of the complex geometry of the fact that, that's good to look at this model here. There's a single ridge on this roof, which is, it's horizontal. But because it's not orthogonal to the walls, it means that those walls are sort of dipping as they, depending on the length of the rafter.
This was something that we ran into in design. Let me see if I can show it in the model. That the top plates, every stud's unique.
Every stud's unique. Every rafter is unique. But the relationship, the geometric relationship of how those rafters come and bear upon that top plate of the wall is actually not unique. That's its same. And so I've asked a student to model that joint to see whether we're actually going to have the studs that receive that plate, whether those studs are actually going to be cut on a complex miter to have that top plate receive receive the bottom chord of the rafter, so that bottom chord will sit flush, or whether we're going to shim each one, whether or not the actual roof geometry will stay orthogonal to the plan, or my hunch as a carpenter is that we will actually run them orthogonal to the ridge, even though the ridge isn't parallel with the walls. But this is something that we're going to test with this model here that you're looking at. Do a physical mock-up as well before we get 25 feet up in the air on the site.
And I think that's really one of the best points to really drive home about this, is that physical models, physical mock-ups, digital models, sketches, even little prototypes, they all need to work together, because it's all about really trying to figure out the issue and solve the problem before we're up to that 25 feet up in the air. And somehow they all work together. It's not one single solution that takes care of everything. We don't abandon everything we've been doing for years. Somehow we find ways of working with them all together and trying to pull out the best features of each.
Absolutely, yeah. And I mean, this is another an arrow in the quiver. I mean, it's an amazing tool now that we have to utilize. Yeah, I always joke that ultimately what we do over the course of the summer is build a full-scale model.
That is true.
Model, and it allows us to test a lot of the assumptions that are made, whether it's with the chipboard models, with the hand sketches, or in the case with the Revit model. We begin to test those and see how the assumptions made in the studio actually manifest themselves in space. And questions of scale are a big thing that come up. You draw a threshold at a quarter inch equals a foot, and then you're walking through that same threshold 2 months later. That ability to sort of translate what you generate in the studio as a design process, and then you begin to sort of be able to literally sort of consume, or that sense of scale of a drawing or a model as it becomes in full scale. It's a really interesting and great educational opportunity. It goes back and then it reinforms the next time they tackle their next design problem.
Actually, let me go ahead and I always like to sort of, towards the end of the hour, really start thinking about lessons learned and things you'd really like to share with the audience, because really we have other faculty online who really are, they're thinking about this, they're seeing this fantastic example, and they're in the back of their mind wondering, gee, I'd love to try something like that, but how would I even sort of get started? So I want to hear about it from both perspectives. Actually, Katie, how about first from your perspective as a student participating in this process? Can you comment on, if you were talking to other faculty about really the value of this, and should they try things like this? What does it mean to you as a student to actually have this experience and kind of see it through and now be building it? So, what would you say to faculty about that experience?
Well, I think it was helpful to use all the tools that we've been using, like the CAD and Revit. At different times, the drawings kind of were dominating, or the 3D model was dominating, and it was helpful to be exploring the building in all different modes, in physical models, drawings, sketches, everything. So I think the more you can do and kind of investigate the building in different ways with different programs, I think that was very helpful. I think
Actually, I'm even going to pull you back a level and say, even go back to thinking about just the whole building project experience, the designing and seeing this all the way through the construction. So not just our week, or because I know taking on something like this seems like such a big task, but I think it's a fantastic and very worthwhile task. I'm a little biased on this one, but what would you say about that in terms of?
I'm a little biased as well.
No, I really enjoyed it. I mean, being part of the individual team and then having everyone come together to work on a single house was really great. I think by the time that we picked the house at the review when it was chosen, everybody was ready to kind of move on to one house and focus their efforts on that instead of being in these different teams. But I don't know, I think everyone has enjoyed the process and everyone is very excited to start building.
Yeah, I think the proof will be in the pudding, right? We should actually sort of revisit this thing in the end of August.
And we can. You don't realize it. You just signed up for another right there. So Adam, from your perspective, as the instructor, you're thinking about the educational mission here, as the contractor who's leading the building side, as the person who had to negotiate with the developers, where do you get started? Like, how do you, what are the key things for anyone thinking about trying to mount an effort like this? What are the lessons that you'd really want to instill with them, about the value and really what they have to kind of do to get going with something like this? It's a fantastic experience.
Yeah, I mean, I think the value of it is really, I would argue, it's an incredible vehicle for learning and for teaching, I should say. And it's really that vehicle has just sort of left the garage. So we're just beginning on this process in a way. And when I said that proof is in the pudding, there's this really interesting continuation of the learning as the students actually take these models and move out into the field and see the translation. Because ultimately, we're not teaching the students to become contractors or to become carpenters or any of that, but to become intimately aware of the processes of actually having it designed be manifest, right? Having the thing actually be built will then inform the way in which designs are developed. Educationally, I think I really do. I think it's a wonderful experience. I think, again, as a practicing professional myself, I find it quite empowering to have the knowledge base of understanding the entirety of the sequence of how a building actually gets made. Ultimately, others would disagree. I would make the argument that architecture is about buildings. It's ultimately its end goal is to produce place and space and occupation. And so I think it's empowering for the students to have this knowledge set. And to be honest, I think it is. If we are going to continue to be relevant as a profession, I think we do have to begin to understand perhaps a little bit more thoroughly the entirety of the way in which a building is actually produced. In terms of, for someone who's considering to develop, to develop a design build program, there are quite a few out there right now. I think the scale of the intervention that we make and the insanity of the schedule that we try to adhere to is well, I think the scale, well, two things. I mean, I'd say the scale, dealing with the building, not necessarily but a building which has to reconcile structural issues, but also thermal conditions and actually creating a thermal envelope. I think that's really critical, that we're not just sort of making shapes. In terms of the time frame, I think what we're doing is really insane, and I would recommend anybody who's considering doing a design build program maybe leave themselves a little bit more time within the curriculum than we have now. Either that or hire a lot more faculty.
Good luck on that one.
Yeah, right.
No, it's such a worthwhile effort. Yeah, in terms of everyone likes to learn from models of success. So in terms of finding out about your experience and stuff like that, are people able to contact you to sort of find out more about your experience? Or
yeah, sure. I mean, you can if you go to just search for the Yale, faculty at the architecture school. I'm there. My email's there. I actually field a few phone calls every year about people who are starting to develop a design build program, and it's actually becoming much more prevalent in the past 10 years. I mean, there are, there's the Yale program, there's the Rural Studio, which has gotten a lot of publicity, and rightfully so. But now we're finding more and more that there are these programs who are really interested in doing design build and sort of cross-pollinating with other programs, whether it's a business school or a forestry school or what have you.
Fantastic. Well, it's getting close to the top of the hour, so I want to encourage our attendees who have been relatively quiet on the chat front. If you have any questions that you want to ask either Adam or not Caroline, but I'm thinking of yesterday. I'm sorry, Katie. Please go ahead and kind of type them on in. We'll try and get them answered. And as we're waiting to see if any of that stuff comes in, I always like to end with sort of this last thoughts, any parting lessons learned that you'd like to share with, again, the faculty who are watching, really about the whole experience. If there's like one or two pithy ideas that are really things you'd like to leave them with out of the whole experience, like Katie, what would you say is like really the big takeaway that you'd like to kind of share with other faculty? Not to put you on the spot.
Yeah. I think just learning about all the different systems at the same time. You're really dealing with everything, from the structural to plumbing to enclosure. I'm getting exposed to everything. I feel like I'm learning a lot about the whole construction process and assembly.
I can kind of pick up an echo on that one a little bit, because it's funny. I'm involved in a lot of classes where we do systems integration thinking, and we kind of talk about all those systems in the abstract, but there's something about on a nice little house project that we can all wrap our head around. You have to resolve all those issues, and you can't just fluff your way through them. You really do have to resolve them right down to where every connection is running between the joists. And I think there's something incredibly valuable about the scope and the scale of this, and really living that all the way through for really learning those. Like, I know when you go into the systems integration class at the end of next semester, it's going to, having had the experience on the house of really working with and trying to model and understand those systems, even as you tackle much bigger projects, I think you have a much deeper understanding. So, that whole thing about working with all the systems, I think, really is very important. And little projects like this are a great way to do that. Adam,
go ahead.
No, please don't. I was just going to turn it over to you, so go ahead and take it.
Well, I was going to just concur with what you say in terms of the scale of the thing, that it actually is forcing one to sort of deal with all of the stuff that happens within buildings. And yet, yes, it's a simple program of a single or two-family house, but it has all those things that do need to be considered and thought through. And that's the intention of doing a project at this scale. And then the only other thing I would say is that again, to understand all of the forces that come to bear upon the making of a project, the sort of internal forces of how students work with one another, and then how they have to reconcile foolish people like me telling them that working or what have you, as well as dealing with a client who has a very particular need, and perhaps even a neighborhood organization who has a very different set of constraints or concerns, and reconciling all of those external forces as well as the internal forces of collaboration, and using the various tools, certainly Revit being one that's becoming so important, I guess. It's a really fascinating process that we go through every spring and summer here.
Fantastic, and I think I'm looking forward to seeing where this finishes up through this summer, and we will bring you on back to kind of do a little debriefing at the tail end to see how it's all gone. But then I'm really looking forward to see where it goes next year, and really even to follow these students through as they take this set of skills forward into some of the next classes and start to see what the impact is. In terms of really thinking about buildings and how they're being built in detail, and how that starts affecting design in some of the future studios too.
Yeah.
Fantastic. Let me go ahead and just kind of wrap up with just a little bit of kind of just the logistical stuff with things that I like to leave people with at the tail end of these. And those are in terms of some of the resources, so people can go ahead and do things like this themselves. A very important place for anyone watching to kind of get engaged with is the educational community site at Autodesk, and students.autodesk.com is the place to go to register for that and get access to free software, any of the tools that we've sort of been using as part of the project, as well as access to a lot of services for doing cloud rendering, cloud simulation, and just kind of collaborating online. So it's an awful lot of good value out there. Everyone should go ahead and enroll in the student community and actually become a part of that discussion, because really I think it's all really about sharing and building community. I think that's one of the best things that's been coming out of this webinar series is we're actually doing a lot of talking and sharing at a level that I think is really quite interesting. So it's all about building that kind of community. There are some specific workshops that people need to know about if you want to focus on the sustainability issues and think about the life cycle cost of materials, or think about how to start thinking about designing a building to drive down towards more of a net zero energy or lowering the energy footprint. Some fantastic software and tutorials available at the sustainability workshop.autodesk.com. And a workshop that I like very much is called the BIM curriculum.autodesk.com. This is one that I actually worked on a few years ago that really tried to take a lot of learning and lessons about how you could actually apply BIM tools, put them together out online so that there are a series of video tutorials that really illustrate an awful lot of just, the concepts that we sort of were working on in class together in the Revit Dungeon. So let me even kind of go popping over there for a second and kind of show people where that is. In the BIM workshop, we have all sorts of different things like lessons on multidisciplinary modeling of structural systems, of electrical systems, plumbing, mechanical, a lot of the different systems here. So for anyone who wants to get started with that and is wondering how to start modeling some of those things in a modeling tool like Revit, the BIM workshop is a fantastic resource of lessons, videos, data sets you can use in class, just a lot of good material out there to help you get started with this stuff yourself. So in terms of wrapping all this, I guess the important things I like to leave people with, it's really all about just jumping in and getting started. I love the notion of just, you don't need to sort of plan this out to the nth degree. There's, you can get started in sort of little ways, and I think even what we did by doing the dual track experiment down in the dungeon was actually a very effective way of getting started with like that, just sort of seeing and exploring and letting it emerge a little bit about how the technology could be used. So people should just really register, download that software, and just start learning about it and trying things, because I think that's really, there's nothing like just jumping in and getting going with it. So from your guys' perspective, from Adam and Katie, like any last, closing thoughts about all that, or is it really just kind of like jump in and get started and try it, or like what would you like to say as we sign off with our audience here?
I think just getting people exposed to it is helpful in this process.
Yeah, at some point, you have to take the plunge, and whether it's a plunge of utilizing software or diving in to get your hands dirty, literally out on the site, whatever it is, I think that what's embedded in a design build program is learning by doing, right? Mm-hmm. And I think that's sort of the ethos that you're preaching as well, which is you just have to dive in, and I think that's how you learn.
The lessons will emerge. They always do. Things never quite go as planned, but a lot of good lessons come out of that. I think you're agreeing with that. Okay, let's go ahead and sign off. Thank you so much for joining us today. I really appreciate your willingness to come on and share your lessons with other folks. I know that a lot of people are going to benefit from hearing about your experience and kind of thinking about how they can apply it in their own classrooms. So thank you so much for joining us. And okay, Adam, I heard you were going to come back and talk about this later at the end of the summer. So stay tuned, folks. There'll be further updates on the building project, and we'll keep on going with this because I think it's a fantastic project, and I want to keep you appraised of. Okay, so thank you, everyone. We'll sign off now, and we will hopefully catch you on the next webinar. Take care. Bye-bye.